Okay, everyone, we start with our next session.
Yes, the session about the available sensors and data. So we already gave you quite some background about the products that we derive, all the things to consider when using the products, and now more about the available data.
So here is a graph which shows a selection, shall we say, of some sensors. And on the bottom, you can see the temporal revisit in days. And then on the y-axis, the spatial resolution in a log scale. The colors refer to different years of launch. So from 1975, I think was the earliest. And then the size of the circle defines the number of bands. And I think what we can see here in this graph quite nicely is that there's quite a clear cluster of sensors. And these kind of define the different applications that they're working on. So the first set of sensors, which tend to be kind of the ones launched from the 70s, which also include meteor satellites, they tend to have a low spatial resolution and a high revisit. So they're looking at the Earth multiple times. Generally, these can be polar orbiting or geostationary orbiting satellites, and they generally tend to be used for meteo or weather applications, ocean applications, and climate modeling. So you're going to hear about some of these applications on Wednesday. Then we have a second kind of grouping, which is a high spatial resolution but a low revisit. So these are some sensors, for example, Landsat, either TM or ETM+. And generally they're used more for land surface temperature applications that don't need necessarily a high revisit. So they generally tend to be from, let's say, 14 to 16-day revisit, but they have spatial resolutions of beyond 100 meters. And then we have this nice grouping up here, which basically defines our upcoming sensors and also the eco-stress sensor. So these have a high spatial resolution and high revisit. And they're going to be a bit of a game changer when it comes to LST research, because they're going to provide data at unprecedented spatial resolutions down to 30 meter or 50 meter resolution for LSTM, for example. And they are going to bring about lots of different types of new research and applications. And on Wednesday, we're going to hear from these three main agency missions. So LSTM from ESA, SPG from NASA, and Trishna from CNES and ISRO, so the French and Indian Space Agency. So we're going to hear all about this kind of grouping on Wednesday. But today we're going to kind of take you through a few examples of mostly sensors that you've heard of already today. Just as a hands up, who has worked with thermal remote sensing data before? Okay, so we have quite a lot of people already working on it. So maybe you might know some of the sensors that we're going to briefly take you through.
Yes, and on that graphic, so this is a graphic that Jennifer created, and it's actually available on our website, where you can download it from.
Yeah. Yep. So I will start a bit with some NASA satellites. So NASA have been developing land surface temperature missions since, well, many years, actually decades. Here's an example of their Earth fleet. So we can see alongside land surface temperature, they have many, many, many other satellites, and I won't go into detail about lots of them, but just to say that they form a kind of constellation with many other types of satellites that look at different aspects of the Earth and the atmosphere. Starting with MODIS. Probably everybody is super familiar with this. So MODIS is a sensor on board Aqua and Terra. So these are two different platforms. It's been running since 1999 until present, but maybe someone in the room can correct me. I think they are starting to deorbit a little bit, so might be going out of action soon.
Terra is going down. Yeah. It's being so currently the orbit of Terra is going lower and lower. So it's actually increasing in spatial resolution. However, it's being also sort of decommissioned. So I think it's still currently operational, but not for very long. That means both MODIS and MODIS only from Terra, so Aqua is still going, but also Asta will be changed. Yeah, just. Yeah. Yes. 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 So for people online, what we got from Jazz as a comment is that the deorbiting also causes a drift in acquisition time, which is also a good reason for decommissioning of the sensor.
So you can see here the bands that it uses and also the spatial resolution. It's a polar orbiting satellite. And with the two platforms, you have a 10:30 a.m. crossing time and a 1:30 a.m. crossing time. And this is also reflected in the AM and the PM as well. You've already seen quite a lot about the algorithms used that Agnieszka presented this morning, but it uses this physically based algorithm to retrieve LST and emissivity together. There are two product types, so this is Mod 11 and Mod 21. Mod 21 is the newer release of land surface temperature. And yeah, here you can find the data product link at the bottom.
And the different acquisition times are reflected in the names. So the Terra is focusing on terrestrial or like land applications, which many of other sensors do, like Sentinel-3 SLSTR. Hence the acquisition time, which was optimized for land applications, whereas for Aqua, it was rather focusing on sea surface temperature, and hence the acquisition time. However, for other sensors, the acquisition time will be slightly different, despite being on land application, and we'll go back on that. A little bit, yeah. So VIRS is supposed to be a continuation of MODIS. It's a newer, better MODIS, and it's being continued. So it is only, so it actually has two satellites. One is Suomi, and the other is Noah, something, yeah. Both acquisition time actually 1:30. The difference being with different resolution in different products. So we'll have the I bands, which have 375 meter spatial resolution, and M bands, moderate bands, with 750 meter spatial resolution. And one other thing to remember is it's a huge swath. And what you see here in that image are those lines. These are not radiometric errors. These lines come from the fact that the products are being binned. And so in order to correct for that huge off-nadir angle, they created the so-called binning. So depending on your application, when I was using VIRS in my PhD, I actually only used the middle part, just to avoid those binning issues. But for your application, it might be irrelevant, or it might be relevant. You need to decide upon that. But that's just so the binning is there in order to unify the spatial resolution throughout the huge swath. There's also a link for the products.
And as mentioned, they use the same approach as MODIS to retrieve land surface temperature and emissivity to ensure the consistency between the two sensors. Next up, we have ASTA. So this is also on board Terra, so on board the same platform as MODIS, and it's been running since 1999 to present. The different thing about this is that it has this ground sampling distance of 90 meters and still at the 10:30 crossing time. However, it has these 5-tier bands that basically allow us to get spectral emissivity, still using the TESS algorithm. And I don't know if many of you are familiar with the ASTA emissivity database, but NASA have been working really hard on using ASTA data to create this very nice emissivity database, which you can use in your own applications. So you can find a link here at the bottom to this database as well. And this is used now as kind of prior constraints to some of the products that Agnieszka mentioned this morning as well.
Yes, and ASTA has never been the same, used in the same way as MODIS, where it's an operational product. In the very beginning, it was a product for purchase, which basically means that even though we have tons and tons of data from MODIS since 1999, we don't do for ASTA. We have selected data sets for ASTA for the first, I think, 15 years or something. at least 10, and then at some point they came to an agreement that they want to act more operationally, and so the data amount increased. So the Aster is an interesting one because it has a very similar spatial resolution to the EcoStress, and it's been there for 1999, which tells us that the technology was sort of there, but the market was not ready to take in so much thermal data.
Yeah. And then the Landsat program, which I guess many of you are familiar with, even if you haven't worked with thermal data, you probably know it well from the optical range. So we've got Landsat 4, I think, was the first thermal sensor on board, and that was from 1982. So you can see that there's a pretty long temporal coverage that Landsat provides. There's two different sensors, so TM, ETM, and then TIRS is the latest sensor that's on board Landsat 9.
8.
And 8. Oh, cool. It has a 16-day revisit, and the different sensors have these different resolutions. So it's 120 meter for TM, 60 meter for ETM, and then back to 100 meter for TIRS. However, as mentioned before in the earlier session, there are some downscaling algorithms that are using the optical bands from Landsat to kind of resample them to a slightly higher resolution. And this has got a 10 a.m. and 10 p.m. crossing time.
Yeah, so when you see a 30-meter Landsat thermal product, that basically means it was the super resolution algorithm was run on it. So it's not the native resolution, but they're available.
And this is part of.
Sorry.
Yeah, no. This is part of the US Landsat Analysis Ready Data products, and they recently released Collection 2. And this is just an example of using the emissivity database from Aster that's used in the app correction algorithms. Going on to ESA satellites, so there's not quite as many as NASA. If anyone has seen an ESA presentation, you've probably seen this slide many times. So ESA have different types of satellites going from science missions or Earth Explorer missions. You have Copernicus missions, so this is like your Sentinels, which probably many of you have heard of. And then you also have your meteorology missions.
Difference being that scientific missions are typically shorter lived, whereas the Copernicus missions are meant to be operational, provide products both for science and also for commercial partners. So basically their longevity is higher.
And Earth Explorers are, Earth Explorers are kind of high risk missions, but I don't know if you can see, where is Aeolus? Aeolus here. So this is the first Aeolus, and now if we look over to here, we have Aeolus 2. So sometimes these scientific Earth Explorer missions can go into operational missions as well.
Yeah, so Sentinel-3 SLSTR is a very important product for us here in Leicester. Also because Darren Gent, the head of our group, has been involved in the mission from the very beginning of it, until Brexit made it a little bit more difficult. But UK is now back in the Copernicus, which makes it, again, slightly easier. So two satellites, Sentinel-3A and B, they're operational using the University of Leicester algorithm, as I mentioned earlier. So the image that you see here, that's the University of Leicester algorithm. Leicester algorithm. They have high temporal revisit, and the spatial resolution is at 1 kilometer. If you want to use or use LSTCCI products, they typically have resolutions in degrees rather than kilometers. So that basically means it's going to be, I think, 0.01 degree, which approximates 1 kilometer at equator. Yeah, it's a continuation to ATSR and VISAT. And yeah, I think that's it.
And then from the meteorology satellites, so ESA have quite a long-standing history here with the Meteosat satellites. So starting with the first generation in 1983 up until present. So we're on the third generation, which was launched last year, the year before, last year before. Okay, quite recent then. So they've been providing land surface temperature from a geostationary satellite at 30-minute temporal revisit. They produce an all-sky LST. Yeah.
The third generation uses a different instrument, FCI.
FCI, okay.
So for people online, the third generation uses an FCI instrument, which is different from the previous ones.
They all produce All-Sky LST. So on Wednesday, we'll be hearing a presentation by Claire Bolden. I think who will be giving us a bit more information about what an All-Sky LST means and how you can produce that. All of the data are produced by EUMETSAT. So this is the European Meteorological Organization. And then data access, so this is the tricky part, right? I've tried to put up here a few examples of different places where you can find all of these different data sets. So for a lot of the NASA data, you can find that on either earthdata.nasa.gov or also Earth Explorer from the USGS. And there is also quite recently, right over on the left-hand side, you can see this Appears website. I'm not sure if any of you are familiar with this or have used it, but I think it was set up quite recently, and it's actually quite a nice way to access not just thermal data, but many different types of remote sensing data. So for example, EcoStress is on there, and you can download spatial data or also time series from a specific point that you're interested in. And it doesn't just have kind of level 2 products, but it also has evapotranspiration or even further products.
To add up on that, EcoStress has quite some issues with image quality. One of them being georeferencing accuracy. What it basically means is that a point which you expect at this latitude and longitude will be shifted. And if you use Appears, you need to accept the risk that your pixels might actually come from a kilometer away. So this is an extremely useful tool, Appears, because it reduces the amount of data that you need to download. Your processing, the processing is done for you. It's excellent, but it does include those errors. So when you use services like Appears, do make sure that the quality flags are downloaded as well, and check what your accuracy requirements are, if you can accept outliers or not. And then you have more information rather than garbage in, garbage out. And one other thing which is very important about data access is that most of those services provide very nice APIs. And what this means is that if you want to bulk download a huge amount of data, you actually can. And you can do that by using some functions, for instance, from Copernicus, or Earth Explorer, Earth Access, and you can automate a download. So restrain your area of interest, give your time window that you're interested in. For EcoStress, it's not possible, but for Sentinel data, it's possible to say, I am only interested in maximum cloud cover per data set of 10% or something, and then it will pre-filter the data for you, and you can then automatically download everything to your given folder. It is extremely useful if you do bulk processing of big data sets. So do look into it, because otherwise you're clicking a lot and that takes ages. So those Earth Explorer, Earth data, they're magnificent to pre-filter the data, look at it, understand it, and then use the API to get it.
These are mostly kind of US developed tools, and on the bottom we have a couple of examples from Europe. So we have the Wekio platform and also the CEDA archive. So for example, for the LST CCI data sets, you can find them all on here and download them there. And I guess, they work in quite similar ways to the ones that are on the top row. And then finally, of course, Earth Engine, you can find all of the data sets, but
not EcoStress, though.
Not EcoStress, but always be careful about the data sets and how they're processed, and always check the quality in there, because
there's even a big article describing differences in the same data set, Sentinel-2, between Google Earth Engine and Copernicus data sets. So it's good to know about all that. This so far has been the agency missions. Do you have any questions on that, and comments, any input for discussion? Yeah.
Is there any method we should make this available to bundle all thermal data products and those from these, but huge stuff.
So CEDA is working on that. That's being worked upon, especially within the EU Data Hub. So yes, there is effort on that. I don't know about the others, though, but I'm specifically involved in including the LSD products into the CEDA catalog through Stack. So yes. Any other questions? Okay, so we have finished the agency missions, a lot of different data products, and then another exciting part is the new space. So there have been a couple of companies that have been grounded in the recent 10 years, and it's changing the image of thermal remote sensing completely, because they're exploring the boundaries, they're pushing the spatial resolution to the limit, making it higher and higher, and therefore it's important to know about the commercial partners. And some of them may even have free data for the scientists, or like non-commercial users. So we might, I think we should have a representative for most of these slides that we're going to show now here on site. So maybe once we show a slide from a specific company, people from that company can stand up and wave. There will be a networking session tomorrow, specifically where you can actually introduce your company. Here we are just focusing on the data products, so we just want to highlight those, show you the contacts to talk to, and introduce you to that. We go alphabetically. So the first company that we're showing is IceTech. So the products available are from 2 bands in mid-wave infrared, 3 bands in long-wave infrared. Here are the wavelengths listed. We are going to share those presentations. We should see swath 20 kilometers at nadir. And the spatial resolution in long wave is 30 meters. For that, I think that's constellation, and the precursor is already there, I presume.
Do we have someone from IceTech?
Yes, is there some?
Yeah,
yes.
there we go. Okay.
Please do correct me. So the precursor has been already launched? Excellent.
Okay.
Oh, right, sorry. Okay, so it's about to be launched with 100-meter in long wave infrared and 70 kilometers watt width. And the constellation is expected to be ready by? Okay, thank you. Yeah, so the products are top of atmosphere radiances, as well as land surface temperature and sea surface temperature, and emissivity per band. The data policy, imagery available at low cost or free for researchers to promote scientific advancement, and ordering is by tasking. Any questions on that? And you can also ask the questions later on in the networking session. The second company is Constellar. Can we see people from Constellar waving? Yeah. Okay. Constellar targets agriculture, infrastructure, and water monitoring with their constellation. They have an in-orbit demonstration, or they had an in-orbit demonstration in Leicester. Then they are launching Hive satellites, which I think the first one's coming soon. Yeah. Okay. Yes, and then the next satellites will create a constellation up to 30 satellites by 2030. Okay. So these are cryo-cooled long-wave infrared detectors with 10 bands, including visible. and the spatial resolution is 30-meter native for long-wave infrared and 10-meter for visible and near, and near. And the product portfolio includes products which are fused as well as the native products. And then we also have the fusion illustration, which shows basically this is super resolution as far as I understand. Okay, right. Okay. So yeah, the Constellar people to talk to. Any questions on that? All right. Then Hydrosat, I don't think we have a representative of Hydrosat here. Okay, sort of. Okay. So Hydrosat launched recently FunZil 1 with global coverage and long wave infrared products at 70 meters resolution with revisit at 6 days and overpass at 10 a.m. They are aiming to create a constellation of 16 satellites. Do you know when is the constellation supposed to be finished? Okay, no worries. If you have any questions on Hydrosat, I can sort of give them further to Josh Fisher, who gave me that slide. So yeah, 2-band long wave in each, and I think they're using microbolometers. So these are uncooled detectors.
And data availability.
Oh yeah,
they have an early adopter product that's available
yes.
now, but it will be free and open for non-commercial academic use.
Yes. Any questions on that? Okay, the next one is Aurora Tech. Do we have an Aurora Tech person? Excellent. Okay, so Aurora Tech is a bit different because the target is fire. So Aurora Tech has mid-wave infrared bands, which are used for fire detection. Their ground sampling distance, the spatial resolution is 200 meters. I think 2 satellites? Green space. Right, okay. Also microbolometers, right? Microbolometers? Okay. Yeah, so the main target here is fire detection. And I think Aurora Tech has already quite some contracts with different governments to enable the fire detection. One very interesting feature here that I would like to point out is the amazing revisit plan for 30 minutes. So that's for the fire detection very relevant. But that's going to be for the whole constellation, I guess.
Yeah.
Excellent. Any questions on that? Okay. And last but not least, we have satellite view. Do we have a person from satellite view? Yes, we do. Okay. So satellite view also uses mid-wave infrared, but their market is slightly different because we're looking at 3.5 meter spatial resolution, right? So you have your first satellite HotSat launched and collected 6 months of data, and the next one is launch end of next year. So data for HotSat is available for the first 6 months of the operation, and with the next satellites there will be more data. Data policy. Sorry, I don't see that. Yeah. Okay. All right.
Oh, cool.
Excellent. Great. Yeah, so also available for completely different user cases here with 3.5 meter resolution. And the products here, I think you're not producing land surface temperature, are you?
No, we're doing so.
Right. Okay.
Right.
Okay. All right. Any questions on that? So I think this brings us more or less to the end of the available sensors and data. Yeah. Do you have a microphone? Yeah.
Did they disappear somewhere?
So I guess I have a question for you and I guess the rest of the audience. A lot of these missions look really similar. And I'm just trying to understand every product is going to be its own snowflake of Calval and data production, and they're going to be very distinguishable to the final user. And I'm asking why. I mean, why, for example, why can't we standardize the payload designs? There could be three companies doing something very similar, but like the same payload. Then you can do different verticals. But I'm trying to understand what is the advantage of having the market so fragmented on things that are so similar and expensive. And probably the companies are executing at the speed they can raise capital, which probably they don't have a lot. I'm just trying to understand if it makes sense at all and how, from the user side, can we nudge the industry to consolidate where it makes sense? Some aspects of the technology, some aspects of the cloud, but don't reinvent the wheel over and over. And I'm saying this from having reinvented the wheel many hundreds of times. So I don't know, that's a question, I guess, from the audience. How do we pressure the market of the providers to consolidate where it makes sense? They can be different where they want to be different, but not build the same mission. Because once you fly at 10:30 in a polar orbit once, the data lost value. It doesn't matter if you fly 3 missions or 1, it's over. It's infrastructure. You don't build 3 roads between 2 cities. 1 road is enough. So how do we think about this?
That's a very interesting question. Thank you for that. And I will absolutely like to invite the audience and especially our commercial partners here to answer. I think we already have some video.
I think I would just give my opinion on this because I think Aurora Tech, like as we as a company, we founded in 2018, but all the co-founders had this idea in 2016 and 17. And to be honest, I'm so sure that the thermal market is not as much as we see now back in those days. And we already decided for the fleet of Constellation in 2018, and we have all the prototypes done. And it's pretty much hard when you know that the competitors or like other partners are coming in, sure that all the sensor wavelengths or all the wavelengths that we sense to be harmonized according to other sensors because it's a fleet at the end of the day and the production takes a lot of time. So that's one bottleneck is what I assume from our side. And it would be also like we're completely up to actually have some kind of harmonization if it all like what we see today is not what we have seen 6 years back. That's the gap I would say. And also, like we are also targeting the late afternoon pass with the OTC plane 1, which means our sensors will able to sense it around 2:30 to 3:30 p.m. because that's exactly where no commercial nor public satellites have an overpass in the MV region, and that's also one of the most important time for us. So it's not just the 10:30 or like the classic 10:30 a.m. pass, but rather the late afternoon pass.
Yeah, I mean, um, regarding harmonization, there's also a big attempt by the currently ongoing by the SBG and Trishna and LSTM teams to do just that. These the orbits of these 3 missions are specifically designed so that anywhere in the world, at the whatever pass time are all 3 satellites. Sorry. Yeah. So just that you know at 1:30 p.m. no matter what, you will always get an overpass by one of these 3 satellites, and they will be like directly intercomparable as if it's one instrument. So following on from that, I just have another question for all of these. So I was not aware that the private sector were coming across over leaps and bounds producing these instruments. Has there been much discussion about validating all of these new instruments, either either coordinating calibration on the ground or validation campaigns that have been set up, or even attempts to look at the existing stations we have and how they might be used in validating these much higher resolution ground pixels.
Yeah, so as far as I know, the participation in Copernicus contribution missions does exactly that. So the companies subscribe to that. I think, then agree to distribute products for scientists, and then also they can get assessed in terms of data quality.
I see.
Validated.
Thank you.
Yeah.
I think just a comment, coming from the private sector myself, I mean, private sector exists because they want to make money. Your big institutional missions like ESA and NASA, they don't exist to make money. They exist to further scientific research and data accuracy and harmonization of data products. But 99% of all institutional missions are the spacecraft or the instrument are made by the private sector. Private sector makes money by making the hardware. The institutions then go and launch it, and they figure out the mission plan. But of course, the private sector has also got, like the ones we've just seen, private sector or commercial customers, again, where the purpose is to make money. So, and I don't fully agree that they're all the same. They may have similar traits, but each one exists for a unique purpose. Otherwise, there's no benefit. I mean, you know, look at smartphones. How many of us have got one particular type of smartphone? Okay, there is one company who has the majority, but the other companies exist for a reason, because they offer something that each other don't. So I think that's why these products are existing.
Yes, I would agree upon that, because we see some companies targeting special needs, as in, for instance, 30-meter revisit time versus 3.5-meter spatial resolution, different wavelength. Here we see agriculture, here we see something different. So I think they can actually coordinate and work together in many cases, obviously not in all of them. Yeah. Technology will be another difference. Some using Hooke's detectors, some using microbolometers.
But I mean, the whole thing is I mean, again, coming from an industry where you have to design a mission, and designing a mission is a massive optimization problem, because you have about 30, not exaggerating, parameters that you use to design your particular mission. And, we are going to choose a certain set that we choose to optimize for, whereas another company will choose a slightly different one because of their use case. So I think harmonization within the private sector is never going to happen, because there's no money in it. So who's going to fund a great big, global campaign of harmonizing all these data sets? No one's going to do that, because there's no money in it. That's sorry, I'm being very facetious, but that's the reality as I see it.
At the same time, what I would like to see in the SIG, maybe in the future, probably far future, but to see the comparison, so that people can take a look and choose the best product for them. And maybe we can facilitate that type of research and comparison. I think there was some other comments.
I mean, I guess my counterpoint is these are very untested markets. I don't know which company actually makes money out of Earth observation. I mean, it's all venture capital. So I would say in other markets that's the answer, but I think the survival of Earth observation hinges on the legitimacy of the data, even for the private customers. And I think harmonizing as much as you can of in particular the supply chain of the instruments, helps the data be more legitimate, actually, and in particular harmonizing spectral bands, shapes, and all these things. Even I would argue the vendor of the filters or things like that makes the data more legitimate. And ultimately, all this data has to be cross-calibrated in practice to public missions. So in the end, even if you don't want to do it, you end up harmonizing in some ways. Might as well just do it by design. That would be my my argument, rather than waiting 5 years later and reacting to it.